Okay, hello and welcome to Math 2's. We're going to do problems number 5 through number 11, or a couple of the problems from 5 through 11. Number 5 says for each equation part A through D below, determine the input values, so our x values, that's what we want to find. And that give the smallest possible output. In other words, what's the x value of the lowest point on the graph, and what is the input value that gives the largest possible outputs, or the x values, or the highest point on the graph. So it does say graph, right? So my advice is to actually graph them. If you don't have a graphing calculator, problem number 6 actually does come with an applet that actually will let you graph, and you can actually put some of these in there. But I'm going to do A and D, and then B and C, you're going to have to do those on your own. So for part A, I don't know what the hint is, so I'm just going to kind of ignore that. So from part A, we're going to do y equals, on the graphing calculator, turn it on. Can you see that? Oh, that's really bright. Y equals, let's clear this. So x minus 1, close parentheses, square it. Wow, that was weird. We're going to square this. And then we're going to graph it. And it actually comes out to, okay, so there's a vertex, and it's obviously not in the center. So it's definitely not the parent graph. And it's shifted to the right-hand side. But we want to know how far in. So we're going to zoom in. And then we're going to press enter again. And then see that it actually bottoms out at 1. Okay, so I'm going to sketch this for you guys. Let's see, we have that. Here's our sketch. We really just want it in the first quadrant. And it's at 1, and it goes wee. Okay, so it looks something like that. And if we actually look closely, we can see that there is probably a y-intercept somewhere at 1 also. So it probably does hit it somewhere at 1 over here. Okay, so here is our parabola. The question is, what's the lowest point? Well, it turns out that your vertex in your parabola is either going to be your lowest point or your highest point. That's the min and the max. So technically the vertex is at 1 and 0. Well, 1 and 0 correspond to the x and the y. So the biggest, so technically the smallest number for x that we can plug in is a 1, which produces the smallest value for y that you can get. And this case would be a 0. So the vertex in this parabola is going to be the minimum point right here. Minimum point. So if it has a minimum point, that means it's never going to have a maximum because it keeps on going up. So minimum point means no maximum. All right, and that pretty much answers part E also. So if it has a minimum point, there's no maximum. And then vice versa, if it has a maximum point, it will have no minimum point. So if it goes up, it's got a minimum point, and your vertex is the minimum point. You need to do the same thing for B. Okay, graph it. If you don't have a graphing calculator, like I said, number 2 or number 6 actually has an applet to use, or you can just come to class before class and do it yourself. And then part D, we're going to plot part D right now, is negative x squared plus 3, and then we're going to graph this. Okay, obviously I needed to zoom out, or go to standard first. Okay, so it's obviously going down because there's a negative in front of the x. So the question is, what's up there? So let's zoom in, and we want to zoom in, if you can see the little tracer, we want to zoom in right where it's at. So we're going to zoom in. Okay, so it's at, y is probably going to be around 3, because look at the numbers. So y is going to be at 3. So have something that hits it at 3, and then comes down in that direction like that. So our maximum point right here is the vertex. It's a maximum, and it's at 0, 3. So there is no minimum. So no minimum. All right, so that was 9. No, that was number 5. Okay, number 6. It says sketch the graphs of f of x equals x squared, negative 2x squared, and negative 0.5x squared on the same set of axes. So it actually comes with the graph with you. So you can actually turn these on to graph it. So since it already does it for us, I'm going to do the parent graph in green because, you know, that's where it starts at. So the parent graph is going to be at x squared. So that's going to be at, starts at 0, 0. And then 1 and 1. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. But that's already off the grid, so I'm just going to follow along. Okay, so this is the parent graph of y equals x squared. All right, now the next one. Let's do that in... We'll do that in orange since it's a nice contrast color. So negative 2x to the second power. So if you're going to graphing calculator, this is why you guys need to get one. Negative 2x squared. And I think that's it, right? Okay, negative 2x squared. Okay, so we're going to graph this. Obviously, I need to zoom. And let's go to standard. Okay, so it hits it in the middle. It looks like probably where my vertex is, but let's check in. So we're going to zoom in the middle. Okay, so zoom in the middle. It's x squared, so it starts there, and it's probably going to be just a little bit narrower than the normals, but it does go here. And then if you actually make a table of values, if I can remember how to do that. Second table. Ooh, it gives me values. There it is. 0, 0. 1 is at negative 2. Okay, let's get this graphed. So 1 is at negative 2. Oh, this is nice. 2 is at negative 8. It's right here. And then it's obviously the same on the other side. Okay, so 1 is at negative 2, 2 is at negative 8, and then after that it can't fit on there. So 1 is at negative 2, 2 is at negative 8. So it's going to go like this. Ah. Okay, I totally messed that up. That's okay. Alright, so that's y equals negative x squared. We have 2x squared. Okay, and then the last one we'll do in blue. Nice blue color. Okay, so the last one is negative 0.5 x squared. And when we graph it, oh, it's just a little bit wider than the other one. Well, actually not a little bit, it's a lot wider than the other one. So let's go to table. So 0, 0 for both. And then 1 is at negative 0.5. 2 is at negative 2. 2 is at... So, sorry, I'm graphing this part right there. And then 1 is at negative 0.5, so that's halfway, right? 1 is at negative 0.5. 4 is at 8. 4 is at 8. And 3 is at negative 4.5. 1, 2, 3, 3 is at 4.5. Okay. So obviously it's a little wider. And then we match it on the other side because we're slightly lazy and we don't want to work too hard. Is it right? Yep. Okay. Da-da-da. There it is. So y equals negative 1/2 x squared. Okay, that was number 6. Hopefully you guys do a good job with it. Alright, number 8. Okay, number 8 is really the bigger issue to fry here. Okay, so number 8, some of you guys will remember how to do these. If you don't remember how to do these, here's your crash course. Alright, I'm going to do part A, and then the rest of them need to be treated the same way. So we have, so from last year, we did, okay, so you have 6x minus 1. So instead of the less than sign, we're going to change it to an equal sign. Okay, we're going to solve it. Add 1 to both sides, you get 6x equals 12. Divide by 6, you get x equals 2. Okay, so now you need to do a number line. Okay, 0 goes here, 2 goes here. I know we could put some more numbers. Here's a 3, here's a 4, maybe a 5. Most important is the 2. The first thing you need to realize is, since 2 is your boundary point, I don't remember if you guys know that word or not, but that's the word that we use. And technically it's an open circle because it's just a less than. So we're going to do an open circle. The question is, which side does it get shaded on? So you need to check. So here's how you check. You just pick a number from, I don't know, the left side or the number from the right side. So let's say I pick a number from the right side. Let's say I pick 5. So I'm going to check with 5. So checking means I say, okay, well, 6 times 5 minus 1, is that less than 11? So 6 times 5 is 30, minus 1, is that less than 11? That's 29, 29 less than 11, that's false. Alright, so this is false. So you don't shade that side. So you can check the other side. So if picking a number from the right side of 2 didn't work, pick a number from the left side of 2. Okay, well let's pick, I don't know, 0, right? So 6 times 0 minus 1, is that less than 11? 6 times 0 is 0, minus 1 less than 11. So 0 minus 1 is negative 1 less than 11. This is true, right? So it's false here, it's true here, because you picked 0 from this side, so that means the shading goes in this direction. There it is. And then your final answer, because you actually need an answer, is x is less than 2. X has to be less than 2 in order to make that inequality true. And all of them need to get done this way, A through D. Okay? If you don't like the fractions, just turn them into decimals. Okay, next one, number 9. How many sides does the regular polygon have if the interior angle has the following measure? Okay, this is kind of the long way to do it because I think the book has this part to it. There's a shorter way. If the interior angle is 60, that means the exterior angle is equal to 120 because together, when you add them up, interior plus exterior has to equal to 180, right? So if your exterior angle is 120, well, 360 out of 120, which is how you find how many sides, technically, clear. 360 divided by 120 is 3. So this is a 3-sided polygon, which makes sense since you have a triangle and each angle is 60, 60, 60. So this is 3 sides. Okay, same thing here. Exterior angle, 156, take away 180 minus 156 is 24. So your exterior angle is 24. Right? This is interior 1. This is the exterior 1. 360 divided by 24. I don't know, 360 divided by 24 is 15. So you have 15 sides. Alright? 90 needs to do the same thing and 40 needs to do the same thing. Interior plus exterior should always add up to 180 because they're a straight line. 90 plus what? Exterior is 180. 140 plus what is 180? And then 360 divided by that number should give you an answer. Okay? Alright, that was 9. And then number 10. Okay, we're going to have to solve a system of equations here. This is going to be a little long, but that's okay. We're going to do this the way that we know how. Okay, so it says graph the system and identify the point of intersection. If you don't know how to graph these 2 lines, please see me individually. We need to make sure you actually know how to do these 2 before we get to chapter 10, or even the second part of chapter 9. You need to understand how to graph the slope, understand how to graph the y-intercept. So solving them is going to look like this. I'm going to write both of them out so I can get them out of that top corner. So you have y equals 1/2 x minus 9. All right, so the easy way to do this is to do the equals values method, which I think some of you guys are familiar with. Since y is equal to this and y is equal to that, they're both equal to the same thing. So that means that negative 2x plus 6 is equal to 1/2 x minus 9. Since they're both equal to y, then you can set them equal to each other. So negative 2x plus 6 equals 0.5x minus 9. There's no reason to keep that fraction if you could just turn it into a decimal. I think I'm going to add 2x to both sides. So 6 is equal to 2.5x minus 9. I'm going to add 9. What is that? 15 is equal to 2.5x. Right? I'm just solving for x, guys. This should not be a mystery right here. 2.5. So x is equal to 6. Okay. Part 1 done. Okay, x is equal to 6. You still haven't solved for y though, so you need to plug it in. So you pick the easier one. My advice is to pick the one on the top. It really doesn't matter, but you can do whatever you want. So y equals negative 2 times wherever the 6 was. It's got to go in the x spot. Okay, and then plus 6. So you have negative 12 plus 6. So you have negative 6. There's your two answers. All right. So your system of equations, those two equations, has a final answer of 6 comma negative 6. This is the point where the two lines intersect with each other. All right. And then there's obviously more than one method to do this, but that would probably be the fastest thing ever. So if you have any questions, and like I said, if you don't know how to graph those two lines, to actually graph them to check to make sure that they intersect each other at 6 comma negative 6, then please see me during tutoring or in class really quickly, and I'll show you what to do. All right. Have a good one.